If you didn't see my Slack message, for the life of me, I can't get Blackboard to accept a new assignment. So I have to have them check my account or something like that today. So email me your screenshot and self-evaluation for the assignment for today. If you didn't see it last night, just send it to me sometime this morning, and I'll get it into Blackboard. You might end up seeing it show up as an assignment that's due once they fix my account, but then you don't have to resubmit it. I'll go through and make it right in there. All right, so let's look at that quickly. All right, so what were we supposed to do for that homework? What were all the features?
When our golem died, we had to be invulnerable for a couple seconds before it respawned.
Okay, and we're supposed to, so this gave us practice turning on and off colliders and things like that, right? Okay, so let's go ahead and we're going to open up our scripts. So we have our, I'm going to open up the Golem movement script. I don't remember where we put it. Did we put it in there? Did we put it in the pumpkin? Who knows they hit who? Because we certainly could have done this in either side. We could have written the programming logic for the pumpkin to hit or the golem to hit. Remind me, what does it mean for a collider to be a trigger? Why would we do that?
So that when like two colliders hit each other, we are able to write a script that like allows a special interaction.
Okay. But we can do that anyways, can't we? Like, yeah. Here's that script that you're referring to, and here's an alternative script on collision enter that gets called anyways.
Yeah.
So in either case, we can, whether it's a trigger or not, we can write some code to do some stuff. So what makes triggers unique? Whether you can turn them on or off or not, what does it mean for them to be on? Nothing?
Is that when we were able to see them in the console?
It's no physics. If triggers turned on, collisions will be detected and it'll get thrown to code, but there will be no interaction using the physics engine between the things that collided with each other. So we effectively are disabling physics playing out among rigid bodies with triggers. We just want to know about it programmatically. Whereas a normal collider or a collider that does not have trigger turned on, it will by default operate with physics and that stuff. We can then optionally have code behind that on trigger or on collision enter. There's also an on collision exit and on collision stay. There's a couple of different functions we can write depending on which aspect of a collision we care about. We can write code that responds to that. So like, for instance, on collision exit means that two things had been colliding and now they stopped colliding. So maybe while two things are colliding, we want a certain animation to play, and then when they stop colliding, we want that animation to stop playing, something like that. Maybe you have a game where your spaceship or something has a shield, and as you're bumping into something that would do damage to you, your shield is flashing or something like that, and then maybe you're taking some damage on your shield, and then as soon as you stop colliding with that object, then that animation stops. So you're not just sitting there with nothing hitting you with your shield pulsating and stuff like that. Makes some sense? So you might want to have different points in time when you can respond to a collision, but a trigger specifically says whether or not physics will play with this object. All right, do we have that in here? Let's throw that in here. So trigger, we're going to call this guy a property of a collider that dictates whether or not physics affects the attached game object. When trigger is on, no physics. When trigger is off, there is physics. All right, that makes sense? All right, so that's our trigger stuff. So right now, if we go back to our Unity and we click on a pumpkin that has this pumpkin script attached to it, notice we have is trigger turned off currently. So we want real physics to happen among these guys. Now we could choose whether we want that to be the case or not, right? Maybe you want your pumpkins to bump the golem around or something. Maybe you don't. It all comes down to how, like if your golem has like a death animation or something, you know, maybe you don't want him to be falling on the ground as the pumpkin is dragging him off the screen or something, but you can kind of decide what behavior you ultimately want. For right now, we'll just go ahead and let them not be triggers. So, you know, for the moment that our golem is dying, he will be being pushed around by the pumpkin. All right, so then back here in the script, we have our on collision enter. So right now, we already have our code here. What are tags? What's the purpose of a tag?
Did you put it on like a bunch of different objects?
Yeah, so any game object can have a tag. Why would we want a tag?
Because you can tag an object and then that object is put in a category that applies to that.
All right, because we might want to differentiate, especially with collisions and things like that, we might want to differentiate objects from each other. Now, so we can have, for instance, all the pumpkins tagged pumpkin or something like that, so that every single time we interact with a game object that happens to be a pumpkin, happens to be tagged as a pumpkin, we can then do something. Similarly here, we have player. We could have golem, whatever we want, but we can tag objects if we want to be able to uniquely determine whether or not we hit an object. We can use a tag to be unique on a single game object, or we can create a single tag and use it on 500 game objects. Either way, we can ask whether the game object we just hit has a certain tag associated with it. Okay, so that's the reason for tags. So if we go back out here, we notice that our golem in the scene is tagged player up here. And our prefab for our golems is also tagged player. So when we instantiate a new golem, he will be a player as well. Okay, that way pumpkins can keep bumping into him. All right, so a couple ways we can accomplish this. Come back in here. If we've collided with, this is from a pumpkin's perspective. So if a pumpkin has collided with something that is a player, we care. Otherwise, the pumpkin's bumping into the floor, and we don't want anything to happen when he's bumping into the floor. So when a collision enters, if that collision was entered with a player, then we want to do some stuff. What are we doing right now? We are destroying that player. Then we're starting a coroutine. Respawn golem. Coroutine, we wrote right here. Right now, we're yielding for 2 seconds. So we're waiting for 2 seconds, and then we are dropping our golem back into the scene. Now, we're instantiating a golem. Now, notice with instantiate here, we actually get the game object that was just instantiated. So this guy returns that game object for us, and we can do stuff to that game object if we wanted to. So we have some different approaches to this. So one thing is we can do, you could choose not to destroy your golem and instead just make him invulnerable for 3 seconds or something so he can get out of the way. That's one thing we could do, right? So let's look at that as a starting point. So up here, we have our golem game object that's associated with our pumpkin. This was for our prefab. But in this case here, we have the dude that we collided with. The game object we collided with is the player. Rather than destroying him, we can go ahead and, let's see, we'll make a public game object player we collided with. Make it really spell it out there. All right, so this is the player we collided with. So rather than destroying that player, we're going to go ahead and we're going to get the player we collided with's collider and turn it off. So we're going to go ahead and we're going to say collider C is equal to, actually let me do this first. I'm going to say this dot player we collided with is equal to collision dot game object. So that's the dude we hit. So if we bumped into a player, I'm going to go ahead and I'm going to set my global variable player we collided with equal to the game object we hit, which is a player. Then I'm going to go ahead and I'm going to grab that player's collider. And in fact, we might want to actually store that collider globally since we're going to need it on both sides. So I'm going to say, and this can be private actually. Making a variable up here public does what?
Well, it's going to be seen in Unity.
Okay, so it exposes it to Unity. So I'll make this guy private because we only need this to be local. Then I'll make another private variable, and this guy will be a collider. And we'll say this is the collider of the player we collided with. Very spelled out, but we know exactly what that variable's for, right? And that's probably better than just a random like collider C. All right. So what I'll do here is after I've marked the player we collided with, I'll then say this dot collider of the player we collided with is going to be equal to, I need to extract the collider from the player that we just collided with. So I'll say this dot player we collided with dot get component, and I'm going to get his collider component. All right, so a game object is a transform plus a collection of 0 or more additional components, right? That's what a game object is. So I can ask this game object to get me one of his components. Specifically, I'm asking him for his collider component, and this will give me that collider. Does that make sense? So an important connection for us to make there, and we probably already have it on a slide, but I'll write it on another slide. For instance, on a quiz sometime, if there was a question, what is a game object? You could say something like, it is a transform, which is a 3-vector 3s for position, rotation, and scale. And then it is 0 or more additional components, where a component is something like a collider, rigid body, etc. Any of those things we can add to that list. It could be a script. All right, that makes sense? So we have a collection of components that are part of a game object. So what am I doing in here? I'm saying, here's the game object we hit. Then I want to extract from that game object his collider. Now notice that you will get an error here if you try to extract a collider from something that doesn't have a collider. Okay, so you'll get some red errors during runtime when you try to ask a game object you just hit to give you a collider when it didn't have a collider. Now, that's not really possible in this situation, given that we are on collision enter, so it must have a collider. So we could very safely assume it has a collider, otherwise we would have never gotten into this function. But we're going to go ahead and grab the collider associated with that guy. And we're setting it to our global variable up here so I can access it from both in here as well as my respawn golem function, which I'm calling right now. But actually what I'm going to do is I'm going to write a second function instead of respawn golem here, just to name it correctly. We're naming our variable so verbosely we might as well. So we're going to call this guy, actually respawn isn't a bad name. We're not bringing him back into existence, but we are turning his collider back on. So that's actually probably an okay name for it. We don't need to rewrite it. All right, so before we start our coroutine, we're going to go ahead and turn this collider off. So we'll say this dot, what is it called? Collider dot enabled is equal to false. So we're going to disable his collider. Then we'll start our coroutine. Here's our coroutine. We're going to wait. How long were we supposed to be invincible for? 3 seconds?
Yeah.
But whatever, right? Whatever you want to. I'm lost. There we go. All right. And then rather than instantiate a brand new golem, well, I'm just going to comment this out for right now. We'll go ahead and turn his collider back on. So we'll say this dot collider, the dude we collided with, dot enabled is equal to true. So we'll turn it off, wait for 3 seconds, turn it back on. One possibility, right? In the real, if we were writing this game for real, we might want to kind of have our guy maybe become a little translucent or flash a little bit, kind of letting us know that he's in some sort of special mode for that period of time. Right now, he's going to look the same. He just won't be able to have stuff hitting him. All right, so let's go ahead and run this.
I think, did you look at Golem's movement yet?
Oh, because we turned that.
Yeah, because that's where you showed us how to get the light.
Right, yeah. We turned it off there. Yeah, here was our example from last time where we grabbed his collider and then disabled it. So let's just zip that out of there. That was our example of how to do what we just did. All right, so he should be back to normal and not fall through the floor now. Oh, we hovered him above the floor a little bit when we were testing that, but it's okay. All right, so we'll go ahead and get hit. So so see, he's actually sinking there. Yeah, so now we're back on. So one thing we can do, we don't want him to sink, obviously, right? So he keeps getting hit. We're going to probably start sinking again. We get hit there. Okay. So now he's invulnerable for a period of time. And then he pops back up and collides off it. But we don't want him to sink at all. How do we fix the sinking? I mean, I think we have a reasonable approach right now to turning his collider on and off. But if we don't want him to fall through the floor, what can we do to that guy? Yeah, on the rigid body, we can freeze his Y for his position. So we'll come here to the golem. I'm going to zoom in on this guy, and we're going to look at it from the side. Actually looks okay. Let's just assume that's perfect. It actually barely moved it. All right, and then we're just going to go to his rigid body and we'll freeze his position on Y. So now, regardless of whether or not he's colliding or not. Okay, so now he moved backwards. Why did he move backwards? Because he collided with the thing. He still has physics turned on, right?
Oh.
So he collided with the thing that he was standing on, and since we couldn't move him up or down, he got pushed back on the ramp because he did collide with the floor. So we probably also want to freeze his rotation or freeze his position on Z to keep him moving from either direction. And we could probably also bump him up in the air just a little bit more. Maybe that's why we had him at something like that. See if his toes are in the floor again. Yeah, he bumped off. All right, so we don't want him to ever move backwards anyway, so we'll freeze his position on Z. We don't want to freeze his position on X because we'd like him to be able to move back and forth. All right. Yeah, so actually right now he's constantly colliding with the ground. The first pumpkin bumped me out of the ground, so I'm back in business. So we need to elevate him a little bit more as a starting point. That's why we actually had it higher, I think. Oh, his collider is actually pretty far down. So really what we can do is back to the Golem. I'll go to his collider. We're going to change the center of that collider. Yeah, something like that. All right, so now I should be able to sink him down as a whole. We're definitely in the ground there. Let's see what that looks like. We'll just call that good. We can sit there and play with the pixel or something, but he's not falling over anymore. We can move back and forth. All right, so he gets hit there. And now he's invincible, so on and so forth. All right, so that's one approach to it. We cannot have our guy actually die and instead bring him back in at a, he's still kind of hanging out there, and the pumpkin he just hit is still kind of bumping into him and stuff like that. So maybe not necessarily the way we want to have this work. So another approach we could do is we could destroy our golem. Then we can bring him back into existence at some future time, maybe after 2 seconds or something like that, to allow the pumpkin to just hit him to kind of roll by. But then what we can do is we can reinstantiate him, bring him back, and then we can make him invincible for that 3 seconds so he can kind of move out of the way of the current situation. Make sense? All right, so let's go ahead and destroy him and have him come back, and we're going to actually do this with 2 separate coroutines. All right, so upon impact, we will destroy our guy. We're going to not get, I'll leave the code in here. We'll not grab the player or the collider because we're going to have a fresh player and collider when we reinstantiate this guy. We'll go ahead and start our coroutine to respawn. We'll wait 2 seconds. We'll instantiate a brand new golem who will come into the fray. I'm going to go ahead and I'm going to say game object new golem is equal to that, because I want to go ahead and I want to grab the dude we just instantiated. I want access to him. Okay, and you'll see why here in a few minutes. All right, so create a new dude. He's now in the scene. We instantiated him. He's in the scene. I just went ahead and gave myself access to him so I can programmatically do stuff related to him if I wanted to. All right. Now we're going to go ahead and we're going to get this Golems Collider. So we'll say Collider. Actually, I'm going to Collider of, well, we'll just leave the names. It's fine. So I'm going to set his collider right here. Steal this guy. Bring it up here. Except I'm no longer extracting it from the player we collided with. Instead, we're extracting it from the new golem we just created. So we're asking our brand new golem to get his collider component. So we instantiated golem. He's now actually in the scene. We have access to him through this variable called new golem. We'll ask new golem to give us the component associated with him. We'll set our global collider equal to that collider. And then we will disable that collider. So now he's invincible. So if we just let it run right now, he's going to get hit. He's going to disappear. 2 seconds later, he'll pop back into existence, completely invincible forever. So we're on cheat mode right now, right? All right, so we're hit. Now we're back. Oh, why is he sinking right now? Didn't we turn the his rigid body's constraints for X and Z off? We did not. So we did it to our original golem. We did all this work to set his, well, I mean, you know, it took heavy lifting and stuff to hit these 2 checkboxes. We hit these two checkboxes, but this dude is based on a prefab. If we want all of our prefabs to have the same stuff happen to it, we need to go up here and hit apply. Because what did we just do? We killed off the golem that's in the scene, then we respawned a new one from a prefab that didn't have those constraints set. Does that make sense? All right, so I obviously did that on purpose. I didn't, but I wish I had. So we're just going to claim that I did. All right, so now he'll behave the way we said that he'll behave. I love that look when the pumpkins like fly up in the air. It just looks so dangerous. All right, so now we're back in business and we're invincible forever. All right, everything will just flow right through us. All right, but we only want to be invincible for 3 seconds or whatever you decide is the right delay. All right, so what we're going to do then is we're going to create another coroutine that will yield for 3 seconds and then turn it back on. Make sense? So have one coroutine call another coroutine. What does a coroutine do? What's the purpose of running a coroutine? What are the advantages of that?
I guess, like you mentioned that before, that was like it's less hard for the computer to do instead of like checking if it's doing this every single frame.
Okay. Well, okay, probably true. What do you mean by less hard?
Like it's not.
I think you get it, but let's add some context.
Like, so instead of like the computer trying to the processor trying to compute the whole thing in one frame and then every single frame, it's instead trying to do it like as fast as needed, I guess.
Okay. Yeah, I mean, not horrible. I mean, you're trying to explain something fairly generically that might be situational. You know, because in our case here, we're doing something very specific, turning a collider off and stuff like that. If we were doing that in a frame-based thing, and we wanted to maybe have it go off every, he's invincible for 300 frames, something like that. We can have some counter inside of update, and once it counts up to 300, then we can make the guy not invincible again. Well, the issue with that would be then the faster computer you have, the less time you have of being invincible, right? Because we're now timing it based on frames. So creating a coroutine creates a separate thread of execution. So already every single one of our game objects has a thread associated with it, and that thread is runs once per frame inside of update. Okay, so we have one opportunity to program our game objects once per frame to do things. So as you were pointing out, we only want to put things in there that really need to happen that often. Now, when you have logic like this, where we want something to happen on a timer and things like that, we want it to be based on real time, not based on number of frames. That's when we can go ahead and use a coroutine to spawn another thread. So we're creating some new non-blocking code, so code that doesn't make our update run any slower, doesn't hold our update up. We're just saying, go run this other code in your own little thread of execution. I'm going to keep doing my thing right here. Why this guy does whatever it is that he's going to do, completely separate from me. Make sense? All right, so this guy's then doing his little thing. It might be very specific logic. He might be waiting for an hour. He might be waiting for a player to hit OK to respawn. It's a lot of games say, you've died, you have 2 lives left, continue. You click the continue button, and then he drops down. So all sorts of stuff like that. So we're using a coroutine to manage our timers. So we're going to come in here, and we're going to have our respawn golem, and then we're going to create another enumerator, and we're going to call this guy turn off invincible, for lack of a better name. All right. And this guy is going to start off with a yield. We'll yield, return new, wait for seconds. And we will wait for 3F seconds. And then what will we do? We'll go ahead and say this dot collider we collided with that we set up there dot enabled is equal to true. All right, so first thing we do down here is we destroy our original golem. Then we'll start our first coroutine to respawn him. We wait 2 seconds. We respawn him. We grab the dude that we respawned. We go ahead and grab his collider. We turn his collider off so that he's invincible. Then we're going to go ahead and we're going to start a coroutine. This coroutine is going to be called, what do they call it, turn off invincible. We're going to start the turn off invincible coroutine, which then drops us here, where we wait for 3 seconds, and then we turn our collider back on. Make sense? All right, so let's run this. All right, so we'll get hit by the incredibly dangerous pumpkins. He'll kick the bucket. 2 seconds later, he'll come back. But now he is invincible for a period of time. And now he's dead again. But the idea is that during that period of time, we should have started positioning ourselves to, to get out of the way of these pumpkins. All right, so now we can ask the question. So a couple different ways of fulfilling it. Anybody come up with another way? Go ahead.
So, getting back to just the way I did it, I think, kind of simplifies the way you did it. I just disabled the collider before the wait for second. So when the function was called, it would disable the collider and then wait for 3 seconds and then it would wait. Is that a bad approach?
Well, okay, so you disabled which collider? Did you destroy your game object?
Yes.
Okay, you destroyed it. Then you started the coroutine?
Yeah, so I'd start the coroutine.
Okay.
Get the collider. It would.
Well, you can't get the collider without instantiating them first.
I did it a little different on like the Golem movement script rather than pumpkin script. But regardless, it disables the collider, so enable equals false, and then I would do the yield, wait for 3 seconds, and then I just do
Right, but how did you? So you did destroy your golem. So you did your code inside your golem script. That's fine. Did you actually kill off your golem? Did you destroy him?
Yeah.
Okay, so you destroyed him. How did you get him back? And where did you get him back? You instantiated him somewhere, right?
In respawn goal.
Okay, where was it? The very first line in there? Or did you yield first for like 2 seconds?
So in the Golem movement awake, I have the start coroutine for respawn invincibility, and in respawn invincibility, I have it getting the component, then disabling it, waiting, and then enabling.
Okay, that's right when the script starts.
That's whenever like
I get it.
Movement is traced every time it's instantiated.
I get it. You relied on it. Okay, let's write it that way. Yeah. So what he did is rather than having a and actually that's probably a better way, because what we have right now with our current setup is we have actually that's the way you would have to write it if you did it from the perspective of a golem. Because since you're destroying he had his logic inside the golem script. And the second he destroyed his golem, he told his golem to kill himself, all of a sudden that version of the script is gone. So he had to play the logic game of relying on the new script that was instantiated with his brand new golem to, when it awakes, turn off his collider, then start a coroutine, wait 3 seconds, turn his collider back on. That was the only way he could get at that guy. Because in our case, we're instantiating our golem from a pumpkin's perspective, right? So we've written it inside of our pumpkin script. The script's attached to a pumpkin. So a pumpkin notices when he smashes into a golem. He then points at the golem and says, "You're gone." And then it's the pumpkin's responsibility then to create a brand new golem. He has access to that golem then, and then he can go ahead and grab the collider, turn it off. So ultimately, you're doing the same thing as ours. By him moving his code over to the golem's perspective, he probably did have less lines of code, because what he did is he played the game of handing off between scripts. All right, so let's go ahead and actually write it his way. So I'm going to go in here to my pumpkin, and I'm just never going to call respawn golem. So we're going to say in here, we'll leave the if statement set up the way it is, but at the end of the day, pumpkin really doesn't care that he hit a player, right? He smashes into a player, he doesn't care. All right, we're not going to do anything. So if we start this thing right now, nothing actually occurs. Physics does happen, so our pumpkins and golem will get kind of bumped around and stuff, but nobody's dying, nobody's invincible. All these things are just for show right now because we're never actually calling them. So what we're going to go do is we're going to write the similar logic the way he wrote it from the golem's perspective.
I did actually have the destroy and the start code in there.
On the golem side.
On that.
Okay, so you had the pumpkin kill the golem.
Yeah, and then it would respawn it on the pumpkin, and then I guess I did the invincibility on the golem.
Gotcha. All right, so you did this. You said, I'm going to kill the golem, and then you also instantiated your golem here, bringing him back into existence. So then he did this. So from the pumpkin's perspective, he kills the golem, and then you immediately instantiated him? Or did you do this inside of a coroutine to wait 2 seconds?
I did it inside of respawn golem. Just
Okay.
After wait for 2 seconds, I used an instantiate gun.
Okay. So he did this. Kills him off, starts his coroutine, waits for 2 seconds. Well, we'll go ahead and give ourselves access to the golem. We won't use it. He created the brand new golem. Then from there, he didn't do any of this logic in here. So he didn't have his second coroutine. He didn't have any of this stuff. What he did instead is he went over to the golem movement script. And he took advantage of the awake script here, that when that brand new golem was born, when he was instantiated, his version of the golem movement script called the awake function. All right. So I'm going to go ahead and we're going to grab this guy's collider. So I'm going to say collider, whatever. This dot collider is equal to this dot get component collider. All right, so now we have access to the collider in here. And then what he immediately did, and this will work. So your original golem was invincible for 3 seconds too, right? Because of the way you wrote this. Right when your golem is first born, your very first one, it's going to call the awake function. And then he went ahead and he created an I enumerator. Make invincible. Okay, what he did is he said yield, return, wait for seconds, 3F. I'm missing something. Oh, it's new wait for seconds, right? All right, then he said this dot collider dot enabled is equal to true. We need to make sure we turn it off up here. This dot collider dot enabled is equal to false. So when any golem is first born, even our first one, we grab his rigid body, we grab his collider. We are using the rigid body for his movement. So we grab his collider, we turn his collider off initially. Then we're going to go ahead and start this coroutine. Start coroutine. The coroutine was make invincible. So we start that coroutine, which says wait for 3 seconds. After 3 seconds, we'll turn his collider back on. Now he's no longer invincible. So every golem that's ever born will follow those rules. When he first comes into existence, we turn his collider off. We start a coroutine, wait for 3 seconds, turn his collider back on. Very first golem, the fifth golem we instantiate will all behave that exact same way. Right? So he effectively built his logic into the cadence of awake always getting called when a new object is instantiated. Yeah, perfectly reasonable way of writing it. I don't know if it's better or worse. We certainly have a little bit of difference in behavior in that our golems are always invincible for 3 seconds when they're first born. Not really a problem. I mean, that's what we want anyways, with the exception of our very first golem, but I don't think it hurts anything, right? It doesn't break the game that he's invincible for 3 seconds at the very start. I don't think any of the pumpkins are getting to us by then anyways. So but it is a different logic behavior. Okay, what's this guy upset about? Oh, no, that's fine. Okay, so we'll run this. We'll see pretty much behaves the same way. He's tactically invincible right now. Now he's technically not invincible. We'll have him get hit. Now he's back. He is invincible for a period of time, probably not invincible anymore, so on and so forth. Make some sense? All right. Now, one thing we might want to do, so he keeps spawning right here in the center, which is the starting point. Let's say he was over here when he dies. Would we want him to spawn back to the same place he just started, or he just died from? We can certainly make the argument, right? You know, one's not necessarily better or worse than the other, but just for the sake of learning the stuff, let's assume we wanted him to go back to the same place he was in before. All right. Now, this is actually going to be a good example because his solution just made our life harder doing it this way. But that's okay because it lets us show a better way of doing things anyways. So I'm going to go ahead and stop this from running. All right. So first thing we need to do is we need to, when he collides, we need to go ahead and capture his position, right? We need to get the position of that guy. So we remember where he was so that when we place the new one, we place him in the right spot. Okay. So right off the bat, we'll come into our script here. And the way we have it written right now is our pumpkin knows about the collision. So on collision enter, if we hit a player, before we destroy that dude, we're going to go ahead and keep his location. I'm going to store it locally here for right now, then we'll figure out where to move it. All right. So I'm going to, his location is or his position is a vector 3. So we'll have a vector 3. Call this Golem pause. And this guy will be equal to collision.gameObject.transform.position. All game objects have a transform. What's a transform? It's a collection of 3 vector 3s, a position, a rotation, and a scale. So we're saying game object, I want you to get your transform, and then I want you to specifically give me the vector 3 from your transform for position. Make sense? That's why we're going 2 levels down there. All right, so I'll go ahead and grab that Golem's position immediately before I kill him off. So now I have a vector 3. Is it a problem that we're killing him off? Will I lose his position after he's dead? Does a vector 3 have anything to do with a golem? A golem has a collection of vector 3s in its transform, but a vector 3 is used for things other than game objects. It's just a structure built into the mono behavior in C# that allows us to store 3 variables, an X, Y, and Z variable. So I'm just extracting that vector 3 from my current game object. After this point in time, I have a copy of a vector 3. The fact that it came from some game object is really insignificant. Then I'll go ahead and kill off my golem. So now he's gone, but I still remember where he was on the screen. So now my intention is to go ahead and have that guy respawn on the screen. Well, now we have a problem. I want my, because the way we have it written right now is my golem movement is set up to make this guy respawn my golem. Oh, actually, we're okay. We're going to make ourselves not okay in a few minutes. But we're okay here because it's actually the pumpkin that does the respawning, right? The pumpkin does the respawning here. And since the pumpkin does the respawning, we have a version of instantiate that allows me to put in here where I want him to be. So I'm going to go ahead and I'm going to store golem position globally here. All right, so there's my golem position, so I'll remember it. Then when I go to instantiate my golem, I can do a couple of different things here. I can go here, as soon as I make my golem, I can say new golem dot transform dot position is equal to this dot golem pos. I can do that initially if I want. So create the new guy and then move him to where I want him to be. Now I'm going to create a scenario here where I'm going to die way off to the left. And I think we'll probably see it. You're going to see him spawn in the middle and immediately flash over to the left. It'd be over on the other side of the screen. So our prefab will always have him spawn here in the middle. Yet he's going to die all the way over here. So he's going to pop here and then immediately move over there. Now, I don't know if we saw it, but it definitely happened that way. I'm looking here in the center.
Frame rate test.
Yeah, we're not seeing it on the frame rate, but it's definitely happening that way. So if we want him to actually appear in the other place so we don't have any artifacting or something like that, there is a version of instantiate here. So notice under by instantiate, there's 10 versions of this function. I can provide it the original object that I wanted to do, which is what we're doing now. But there's also a version that allows me to give it a transform for the parent. Actually, that's weird for the way that will work. Let me see if there's another one. Otherwise, I'll explain how the parent one works. It's kind of a, well, it's an interesting way to do it.
If it's spawns in the middle of the rapid, does it mean if like there's pump in the middle?
What's invulnerable anyway?
It's invulnerable for 3 seconds, but otherwise it would if it happened in that little tiny second. All right, so yeah, here's one that takes a vector 3 position and also a quaternion rotation. That's probably the one we're going to use, but the other one will actually work, I think. I'm going to explain how both of them might work. Okay, so I'm going to do the one that just takes the parent first. So I'm going to spawn a golem, and I'm going to spawn it at a vector 3 position, which is going to be golem pause. Although that guy wanted a transform. All right. I'm actually going to make another variable here just to show this. So private transform. Call that golem transform. Down here on our collision here, we'll say this dot golem transform is equal to collision dot game object dot transform. So now we have the entire transform, which is position, rotation, and scale. All right, and really when we say something is a transform, that's a pretty generic way of saying it's a game object, right? Because all game objects have a transform. So those guys are almost interchangeable, except for the fact that a transform does not have a collection of components, where a game object does have a collection of components. So up here, instead of golem pause, I'm going to say golem transform. So I'm instantiating this game object with this parent. And let's see it work first, and then I'll tell you how that's working. I'm going to turn off this next line, which was resetting its position because he should be there right off the bat. Oh, he's not. Interesting. So we actually would have needed it to be a physical game object that was in the scene. All right, so the way the parent would work is, let's say I instantiated an empty game object at the position that the golem died. Then I destroyed the golem. All right. Then I could instantiate a new game object as a child of a game object that's already in the scene. That's what that parent means. And we've seen before that if we want to have like a camera follow somebody or something like that, or we want to have a bunch of things move within a game object, we can make them children of that game object. So when the parent moves, everything underneath it moves as well. Oh, what happened? What did happen?
Creating a wall. None shall pass.
Wonder why so many are able to get created. Is it that the way their colliders are set up? Your golem doesn't bump into other golems. Well, he will physically, but that's why they spread out that way, but they can't hurt each other. Oh. Why do you think it's spawning so many golems? At what point does it start spawning lots of golems? If you look at this code here should tell you. It probably starts off with just 2 golems, or maybe 3 in a worst case, but probably 2. And then as you get more and more pumpkins, 2 might become 4, or so on and so forth. What do we do when our pumpkin collides with a player? What's our logic? It's these lines, right? These lines right here. So we destroy our game object. We start our coroutine to spawn a new one, right? How many golems does this spawn? Not a trick question. 1, right? How many pumpkins might bump into a single golem before he's destroyed? Let's say you have 2 pumpkins that are kind of rolling at the same pace, and they both kind of bump into the golem kind of sort of the same time, or at least enough time for these things to happen before I actually destroy it. So now what you actually had is you had 2 different pumpkins both get into this on collision enter before the original was destroyed. So now both of those pumpkins will go and respawn a golem. So now you have 2 golems on the screen. Now you might have 2 pumpkins each hit each of those golems. Now you have 4 golems on the screen. So on and so forth until you have a wall of golems. And at that point in time, what's happening is as you have more and more pumpkins rolling down there, the chances of hitting 1 or more golems goes way, 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 way up, right? And that's why you just keep spawning more and more and more of those guys. All right, so in operating systems, that type of thing is called a race condition, where you can have more than one thing happen at seemingly the same time. All right. How can we work around this? What if we wanted that never to happen?
So like if there's one on the screen.
Okay, well, that's kind of cleaning up our mess, right? You just have a random thing where if you have more than one golem on the screen. The golem, like, you'll have them play Russian roulette, and there's only one left standing at the end or something like that. But what if we wanted to ensure that it never actually occurred?
Destroy before you get the position.
Well, destroying before you get the positions is going to be problematic because once you destroy, you can't get the positions. But even then, you don't really solve the problem of the race condition. You're basically picking up however much time this took. There's still some stuff that can happen in there, right? Because we're at the mercy of the underlying logic that governs this on collision enter, which we don't have control over. So what are some approaches we can use to handle this? So this is really kind of an operating systems concept that applies directly to game programming. So one thing we can do is we can constantly play this cat and mouse game where we can try to reduce it to the point where it's as if it never happens, but every now and then it might happen. Now, any video games that you play, do you ever accidentally get an extra player on the screen at the same time? That's happened before? Must be a pretty junky game. But in general, in general, you don't accidentally get a player on the screen. So from our perspective, maybe reducing it to a situation where it's very unlikely for it to happen isn't good enough. Probably good enough for our game here, but maybe not good enough for the big scheme of things. So right off the bat, we might say, you know what? Destroying the current game object and instantiating a new one right off the bat brings into the scenario of us possibly having more than one guy on the screen at once because we are creating new golems. The second you create one golem, you might be creating more than one if the script is inside of the pumpkin script. If we move this logic into the golem, from the golem's perspective, can he bump into more than one pumpkin at once? One of those guys is going to hit him first, right? One of those guys is going to hit him first, and he can even have the very first thing he does turn off his collider. So nothing else bumps into him. So now, instead of having the pumpkins notice that two separate pumpkins ran into a golem, now you have a golem who's looking out for pumpkins running into him. And then the golem kills himself off and has a coroutine that, really what you'd have is you'd have to instantly, let me ask the question. If a golem kills himself off, that also kills off all his components, right? One of his components is, in this case, our golem movement script. The dude we expect to spawn our replacement golem. So if a golem kills himself, is there any longer a script to spawn a replacement for him? So I'm the golem. Something hit me. I'm now supposed to die, right? So I destroy myself. And then what? I call the coroutine that says spawn a new copy of myself. But I can't call a coroutine on a script that no longer exists because I just destroyed myself. It's like a chicken or the egg problem.
Did you still have the pumpkins spawn the golem?
Well, who's going to tell the pumpkin to spawn the golem? Well, now we're back to our old problem. So now you have possibly more than one pumpkin that collided with the golem, and now he might spawn two golems instead of moving all the logic over to the golem side. Because in this case, if both of you guys are pumpkins, and you both bump into me roughly the same time, I'm going to notice one of you first, right? My on collision enter is going to get called, and in that case, I'm going to say, okay, I'm going to kill myself, but then I want to in 2 seconds spawn a new copy of myself. Well, I can't do that internally because I'm dead.
Could you have a line where it says create a new golem? Like you turn your collider off, then you wait, or then you create a new golem in 3 seconds, and then kill yourself, and then in the new golem have it be invulnerable. Like just like switch the order between.
So you're gonna first create the new golem,
Yeah.
and then in 2 seconds you're gonna kill yourself.
No, it'll like right after that line, the golem will die. So then there'll be no golems on the screen, but it'll be waiting for 2 seconds to spawn the new golem right after it dies. If that makes sense.
Oh, okay. I see what you're saying. So you want to have a coroutine that waits 2 seconds to spawn a new golem.
Yeah.
You start the coroutine first.
Yeah. And
then you kill the golem. That might work. It's possible. I mean, we can test it here. So are we inside of our golem movement here? Oh no, right now our logic's in there. So let's actually move that logic in there. So we're gonna make a So this ultimately comes down to, how do coroutines work? Does a coroutine get immediately scheduled? So we're going to go ahead and we're going to have I'm going to steal the coroutine from over here for respawn. All right. Now he is going to have to know about the Golem prefab so he can make another copy. And this is where I think things might become problematic. So we're going to let golems know about the prefab that is themselves. I actually think he could probably do it with... I think he could probably make a duplicate of himself. But just so we don't muddy the waters with too many variables at the same time, let's do it this way, where we're going to say this particular golem has a public variable that is a link to the prefab for golems. That link for the prefab for the golems is identical to this particular golem himself. That should actually be equivalent to him just saying this. He can make a duplicate of himself. That should be allowed, but we've seen this work exactly this way, and since we're testing something else, let's just run it this way. So we're going to let the golem and his script, this thing should update here in a second. Big money. Oh, he's not going to update till I have all my errors out of here. So let me just come down into here.
If you kicked all those pumpkins that already spawned, now they roll off the map at the end. Like if they just keep and they're still rolling while you're.
Yeah, I'm still falling.
Does that like affect like?
It absolutely will.
So like, I guess it'd be better to like delete them after. I was wondering because like. You
know what's funny? You literally just guessed your homework assignment. It shouldn't be a bad one, but yeah, I mean, let me just get this fixed up here. So what I'm going to do, just for the, I'm going to go ahead and comment out this. So our pumpkins no longer care about the collision on their side. Then we're going to go over to the golem side. So now the golem with that. So on collision enter, if collision dot game object dot tag is equal to Do we use lowercase p for pumpkins, or do we not even label pumpkins? Uppercase P for pumpkins. That guy is a pumpkin. Then we're going to do some stuff. What are we going to do? He wants to go ahead and start the coroutine first. So start coroutine, respawn golem. And then he wants to go ahead and destroy himself. So he's hoping that starting this coroutine will preserve the kind of the current state of things before his death, because this guy does not block, right? So while this is waiting for 2 seconds, this dude is going to sit here and cook, or sit here and kill himself. Then we're going to go ahead and destroy, and we will instantiate a new one. Let's just run that real quick. It'll just tell us what the scoop is. I don't think this is going to work. I think as soon as he dies, the coroutine scheduler will get kicked off the schedule. Yeah. So as soon as he died, all his coroutines died with him. So his suggestion, which wasn't a bad one, is, well, what if we go ahead and play the coroutine game and schedule our coroutine now, then kill myself? Will this guy still fire in a couple of seconds? And the reason why I was pretty suspicious it wasn't going to work is right here I'm saying this.golem. I'm trying to access a variable of that game object when that game object is now destroyed. So it's kind of a chicken or the egg issue. All right, so for next class, and hopefully I'll be able to put the assignment up. For next class, we're going to have, we have all of these pumpkins that get spawned. And once they fall off the end here, they just fall to oblivion and they live forever. So we want pumpkins to destroy themselves after they are no longer seen on the screen. So figure out how that logic might work. Make some sense?
Are you looking for it specifically as soon as it falls off, or?
Probably. My feeling is as a game player, you probably don't want to see these pumpkins just randomly disappear.
Okay.
So you maybe want to do it based on some sort of either timer or something else. Don't want to give away too many hints, but whatever you're happy with is fine. But think about it from a game design perspective. Maybe you want the pumpkins to be very much out of sight before you just kind of get them off the plate for resources. Cool? I'm in front row of chapel if you want to join me. Plenty of seating.